Okay, so uh, this is on the same side. Okay, just let me go through this. Yeah, this is Q and U. Okay, so basically in this method, what exactly we are doing is on the similar lines of LR method. So we have this A matrix. Okay, so which can be of size 2 by 2 or maybe 3 by 3. Okay, depending on the type of the problem. So in this particular case, if you remember in the previous class, we have divided this into uh, L and U method, L and U. Okay, but in this particular case, you have to divide this into U and Q. Okay, so where U is the upper triangular matrix and Q is the orthogonal matrix. Okay, so once the value of U and Q are done, so we will call this as, let us say, U1 and Q1. So once the values are calculated, you can generate the A1 matrix as the product of Q1 multiplied by U1. Okay, so like this, again A1 has to be broken into two part. Again you generate from A to A1, A1 to A2 to A3, just like we have done in QR method, sorry, LR method, unless and until the your matrix is going to become a diagonal matrix. Okay, here the Q matrix is slightly different over here. Okay, so now basically what exactly we are trying to do over here is to eliminate this as well as this. Okay, so that this is going to become a matrix which is looking like this. Okay, so for this purpose we are following this particular process. Okay, now here once it is getting converted, these two values, they will be nothing but your eigen values lambda 1 and lambda 2. Okay, so now here you just try and understand that we are trying to eliminate this particular element. So this element is A 1 and 2. Okay, so if I am trying to eliminate A 1 and 2, so your Q matrix, okay, so your Q matrix will be something like 1 0 0 and 1, which will be identity matrix. So since it is 2 by 2 matrix, it will be just having 4 elements. And since we are trying to eliminate this particular element, that is Q and 1 and 2, that is first row and second column. So all you have to do is, in place of this, you just write sine of theta, and that too with a negative sign. Okay. The element which we are trying to convert to 0, so that particular location has to be written as minus sine of theta. Okay, so here the subscript over here, it is 1 and 2, that is first row and second column. So if you interchange it, so it will become second row and first column, which will be this particular element. Okay, so now this particular element has to be written as sine of theta. Is it okay? Shall I repeat? So if we are trying to eliminate the location number 1 and 2, so at that particular location, that is, you write the identity matrix first. Okay, and in that particular location you write minus sine theta, that is 1 and 2, you write minus sine theta, and then you interchange the subscript. So if it is 1 and 2, it will become 2 over 2. So at the location of 2 1, you write plus sine theta. Okay, then if you take only rows, that is 1 1, and if you take only column, that is 2 2. Okay, so at location 1 1 and at location 2 2, you just write cos theta. So this is your nothing but your Q matrix. Have you understood this? Shall I repeat? So basically we are trying to convert A matrix into a diagonal matrix. Okay, so in this process we have to eliminate one element in the upper triangle, one element in the lower triangle. Okay, so if I try to eliminate the element which is there in the upper triangle, its location is 1 and 2. So basically we are trying to eliminate 1 and 2. And then if you divide this A matrix into two parts, that is U1 and Q1. So out of that, Q1 will look like this. Okay. So how to get the value of Q1? It is like this. So if we are trying to eliminate 1 and 2, so at location 1 and 2, you write minus sine theta. At location 2 and 1, you write sine theta. At location 1, 1 and 2, 2, you write cos theta, cos theta. Simple. Okay. About your U matrix will be exactly same. So this will be U11, U12, this will be 0, and this will be U22. Okay? Have you understood this? Right. So let us take example over here. So I have a simple matrix available with me. So this is A equals to, we have 4, 5, 5, and 6. Okay. So now I have to find out what are the eigenvalues of this particular matrix. Okay. Simple 2 by 2 problem. Right. So now for this purpose, what exactly I have to do? So this A matrix has to be broken into two parts. Okay. How? This should be the product of Q1 multiply with U1. Okay. So I'm going to write down this expression in detail. So this is 4, 5, 5, and 6. Okay. So let us call this as 6 equals to Q1. So Q1, just now we have seen, this is cos of theta, this is minus sine of theta, this is sine of theta, this is cos of theta, multiplied by, you have U is U11, U12, this will be U22, and this will be 0. Is it fine? Yes, sir. Okay. So now you see the 4, 5, 5, 6 matrix is the product of Q with U. Okay. So now if you see the number of equations which we can generate one equation by multiplying the first row and first column. It should give you value 4. Okay. Like this, you can generate equation which is going to give you value 5, one more equation for 5, and one more equation for 6. So like this, you can generate 4 equations. Okay. So 4 equations can give you answers to 4 different unknowns. How many unknowns are there in this? 4. U11, U12, U22, and theta. Not sine theta and cos theta. Another unknown is theta. So you have 4 equations, you have 4 unknowns. So definitely you can find this. Okay. So for this purpose, let us try to find out these unknowns. Okay. So I'm going to write down one by one equation. So the first equation which I can generate, that is 4 equals to U11 cos of theta minus sine of theta into 0. Correct? Then the second equation which I can get is something like 5 equals to, this is first row and second column. So this will be U12 into cos of theta minus sine of theta into U22. Okay. I think I have wrongly written over here. This is sine of theta into 0. Okay. Is it fine? Then the third equation I can generate something like 5 equals to U11 sine of theta plus cos of theta into 0. Am I right? And the fourth equation I can generate, that is 6 equals to U12 sine of theta plus cos of theta into U2. बराबर है ये? ठीक है? So now if I rewrite expression 1 and expression 3, what I am going to get? This is 4 equals to U11 cos of theta, because the other term is 0, and here this is 5 equals to U11 sine of theta. Okay. So you can solve these two equations so that you can get the value of theta. Can you do this? कितना आएगा थीटा? Let me check. 51.34. 51.34 degrees. Yes, everybody could get this. All right. So one unknown you have successfully calculated. Okay. So now you can use expression 1 or expression 3 to get the value of u11. बराबर है? Okay. So if I substitute the value of theta over here, this should give me the value of u11. That is 4 divided by cos of 51.34. How much is this? 6.4030. So this is going to give you value of u11. Okay. So we have successfully calculated two unknowns, that is theta and u11. Now what you can do is you can rewrite expression number 2 and expression number 4 by substituting the value of theta. Okay. So that you can get two equations which involves two unknowns, that is u12 and u22, and solve. Very simple. So here expression 2 will be 5 equals to u12 cos of theta is 51.34 minus u22 into sine of 51.34. This is, let us say, expression A, and the fourth expression will be something like 6 equals to u12 sine of 51.34 plus u22 into cos of 51.34. This is going to give you expression B. Okay, so you just solve this and let me know the values. Yes, anyone? Give me the value of u12 and u22, please. Just 7.80. Okay, this is u12. 8086. Okay, and 12 is 0.1561. Yes, that's a correct answer. Okay, I'm also getting the same values. Okay, so as a result of this, what you are getting is this, that is Q matrix, or I should write Q1 matrix. Okay, and if you refer the Q1 matrix, it was a cos theta minus sin theta. You just substitute the value of theta over there so that you can get the value of Q matrix as 0.624 बराबर है minus 0.78. This is 0.78 and 0.624. So this is nothing but your Q1 matrix. Okay, as far as your U matrix is concerned, okay, so your U1 matrix will look like this. So U1 matrix is 6.403, okay, which we have calculated over here, and then this is 7.8086. This will be 0, and this will be minus 0.1561. Okay, so you see we have broken the given matrix into two parts, Q and U, such that if you multiply Q with U, you should get your original matrix back, है ना? So definitely you will be getting this. Okay, I'm not going to do the calculations over here, but if you want to have a check whether you have done it correctly or not, you can multiply randomly any of the rows with any of the column, and you should get your original matrix done. Okay. So now with this process, we have broken the given matrix into two parts. So now let us generate A1 matrix. Okay. So this A1 matrix, this will be a new matrix. So this will be the product of U1 with Q1. Okay. So U1 with Q1. So U1 matrix is nothing but we have 6.403, then 7.8086 minus 0.1561, and this will be multiplied with 0.624 minus 0.70, 0.78, not 7078, and this is 0.624. So finally, if you take a multiplication of these two, you will be getting a A1 matrix. Yes, anyone? हाँ U1 into Q1 बराबर लिखा है ना मैंने. हाँ U1 into Q1, बिकॉज ब्रेक करते समय अपन ने उल्टा किया हुआ है. So while breaking, you see we have used Q with U. पहले Q लिखा है, बाद में U लिखा है ना. लेकिन जब हम लोग नया मैट्रिक्स बनाएंगे तो पहले U आएगा, बाद में Q आएगा, जैसे LR में किया था ना. एग्जैक्टली सेम प्रोसेस. क्योंकि अगर Q1 U1 करोगे तो ओरिजिनल मैट्रिक्स ही मिलना है तुमको. Come on, यार, your calc is advanced, right? You just have to fit two matrices directly. It is going to give an answer, isn't it? Sorry, 10.097. Okay, बताओ, मुझे बताओ. I'll write down 10.086. Okay, नीचे. Here. 0 point. Louder, please. 121. Okay, this one. Okay, how about this one? 097. Yes, someone please cross check this. Correct hai? So you see, we have started with A matrix and we have generated A1 matrix. Okay, and what is our objective? We have to convert the given matrix into a diagonal matrix. Diagonal matrix means what? The upper triangle and lower triangle should be completely zero. Can you see, is it zero? No, but it is very much close to zero, isn't it? Because you see the diagonal element is having a value of minus 0.121, which is very close to zero. Okay, and since it is not zero, we have to go for one more trial. So in another trial, again, what you have to do is we have to break this A1 matrix into two parts. Okay, so it will be something like this will be Q1 into Q2 into U2. Okay, so basically all we have to do is write this A matrix, okay, or rather A1 matrix. So this will be 10.086. This is minus 0.121 minus 0.121 minus 0.097. This has to be multiplied with what? Q2 with U2. Okay, so here the वैल्यू ऑफ नहीं, मैंने शायद गलत लिखा है, u with q, not this one. So this has to be rewritten. This is u2 with q2. Okay, so here also if you remember, यहाँ पर भी हमने the matrix is broken into u and q. Okay, so the same matrices will be there. So this will be u11, u12 0, u22, and in the q matrix, the same q matrix will be there: cos of theta minus sine of theta, sine of theta, and cos of theta. Okay, so generate 4 different expressions and get me the values of theta, u11, u12, and u2. ठीक है, meanwhile answer your attendance, sir. U into Q. See, U into Q. U पहले आएगा, नहीं मैंने गड़बड़ किया है क्या? ओहो, Q into U, सॉरी मैंने शायद लिखते समय गड़बड़ करी है. तो Q should be first and U should be later. तो लिखा मैंने यहाँ पर बराबर है, यहाँ पर मैंने गलत लिखा है, रुको. Yeah, this one is correct. Okay, this one is correct, this one is wrong. Okay, this is Q1 into U1. Accordingly, this will also change. Okay, this will be Q1, sorry, Q2 into U2. So this will be completely gone. Okay, and this portion will go over here, and then you have this u11, u12, u22, and 0. ठीक है? That was my mistake. Sorry for that. Okay, now we are doing it correctly. Yes, first shift students, please answer your attendance. Roll number 3, then roll number 4, roll number 5, 11, 14, 17, Amog, online, 23, 24, 45, 46, online, 49, online. अच्छा, roll number 50, 54, online. Okay, 55, online. 61 and 66, 72, 79, 83, 84, then 86, online. Yes, now second shift students, roll number 5, not there, roll number 61, roll number 62, online. Roll number 85, Not there. 91 is online.
Yes, sir.
Chalo, anyone got the answers? Hmm? Theta value in the second iteration? 51.28. Okay. U11, U12 and U22. See, angle sometimes you get negative, sometimes you get positive. Okay. But if you substitute the value of theta, so sine theta and cos theta, they should come same. So please check that because I am getting the angle as 51.3. Oh, sorry. This is for first situation. My mistake. Theta value. Oh, sorry, I don't have the theta value actually. So cos theta is coming out to be 0.999. So it should be very close to zero theta. है ना? ठीक है चलेगा. माइनस आ रहा है प्लस आ रहा है. ठीक है कोई प्रॉब्लम नहीं. हाँ वो जिससे क्वार्टर हो जाएगा. Yes, can anybody tell me the values of theta? कितना आ रहा है? Minus 0.6873. So it's a very small value. Okay, close to zero. How about U11? 10.086. Okay. And U12? U12 and U22. Anyone? Yes. Anyone? भाई कौन सी वैल्यू बता रहे हो वो भी बता दो. हाँ हाँ क्या है? Okay. And U22? 0984. Someone please cross check this. Okay, so you see the Q matrix, Q2 matrix. Okay, Q2 matrix is cos of theta minus sine theta and cos theta. You already calculated the value of theta as minus 0.6873, which is very close to 0. Okay, so I'm sure if you substitute the value of theta in the Q matrix, you will be getting a matrix which is very much close to the identity matrix. Okay, so here this is nothing but your Q matrix. Okay, this is your Q matrix and this is nothing but your U matrix. Okay, so can anybody tell me what is this Q2? I'll call this as Q2. I'll call this as U2. So Q2 is basically cos of theta 0.9999. How about this one? 0.0. Okay, this negative or positive? This will be negative, that is 0.0112. I'm sure this will be 0.9999. Okay, so you see your Q matrix is almost identity I matrix, that is identity matrix, where upper triangle and lower triangle both are very much close to 0. Okay, so this is an indication that we are arriving at the correct solution. Okay, so once the value of Q2 and U2 are calculated, now we can generate this A2 matrix, okay, by multiplying U2 with Q2. Okay, so where U2 is nothing but 10.086, this is minus 0.1208, this will be 0, and this will be minus 0.0984. This is your upper triangular matrix, and your Q2 matrix is 0.9999. This is 0.0112. This is negative 0.0112, and this is 0.999 and 9. So if you do the multiplications, you should get the A2 matrix, which is as good as your diagonal matrix, where lower and upper triangle both are almost 0. Okay, please do the calculations. 10.0854. Are you sure? A2. Okay, and this one? Okay, this is? Okay, how about this one? Yes, someone please cross check these answers. A2. बेटा ये देखो, when you are multiplying this row, okay, this particular row with this particular column, you should get the value which is at least greater than this. तुमको कम आ रही है वैल्यू, है ना? Because you see this is 0.999 and this is minus and minus. Please check the calculations one more time. सेम है, ये वाली वैल्यू चेक करो तो u11 की वैल्यू 10.0 बराबर है ये, ठीक है, ठीक है, ठीक, कोई बात नहीं, probably round off error. So all of you are getting these answers as A2, okay, or very much similar to this one, okay. So ठीक है, we will stop here because you can see that this value is close to 0, okay, and this value is also close to 0, okay. So at the end what we can say that this value, okay, the diagonal value, this is the lambda 1 value and this is the lambda 2 value, okay. So your eigenvalues for this particular matrix is lambda 1, that is 10.0854, and lambda 2 is minus 0.098, okay. And I think we have already solved this using LR method probably. This is 4556, है ना? So if you see this, so you got the lambda 1 value as 10.1 and minus 0.1, ठीक है? ये डायरेक्ट मेथड से तुम लोगों ने सॉल्व किया था, राइट? So 10.1 and negative 0.1, and if you see the values over here, so this is also very close to 10.1, है ना? So let me write down the correct answer over here. So this is close to 10.1 and this is close to minus 0.1. So if you go for one more trial or maybe couple of trials, you should be getting this answer. You might have done the round of error, what we call it, okay, because you are maintaining 4 digits, but if you write the program, so program is maintaining many digits. So in that case, there is slightly difference in values, okay. So in your computer program, the values will be exactly same, and at the end you are going to get this as your final answers, okay. I hope this method is clear to everyone.
Yes, sir.
Okay. Okay. Are there any queries? Yes, are there any queries? So